Hello everyone, welcome back to my new video on AP Physics 1. So this is on Unit 4 about momentum. So let's start what is momentum. So in this unit, we'll talk about linear momentum. And basically, the equation P equal to mv tells us the amount of motion that an object possesses when it's moving or not moving. P is the momentum, kilogram meter per second. M is the mass in kilogram, and v is the velocity meter per second. Note that momentum is a vector quantity. It has the same direction of velocity. Since this mass here is a scalar, that it doesn't affect the velocity, the direction, but it will only affect the magnitude. So let's talk about impulse. So basically, it's a change in momentum by a force. We can see that impulse is force times change in time, the time that force acts upon an object. And this is equal to the change in momentum, which is the momentum impulse theorem. And when there's a non-constant force, then you can calculate the area under the force versus time graph to calculate the impulse. Impulse is Newton times second. We can see that it is equivalent to kilogram meter per second. If we recall Newton's second law, F equal to ma, the Newton is equal to kilogram meter per second squared. And if we multiply by second, this will give us kilogram meter per second, which is our momentum unit. And this also shows that a force that changes an object's velocity must act upon an object for some certain time. Because when the time is equal to 0, it doesn't do anything to the velocity. It doesn't change the motion. So let's talk about Newton's second law. So we learned about F equal to ma in Unit 2, but really what Newton said is that the change of motion is proportional to the motive force impressed and is made in the direction of the line that the force is impressed. So what does it mean? Is that the force, it acts on the objects, it changed object's motion that in the same direction as the force. Okay? And really, force changes the motion. You can see F and delta P. And really, it shows us it's the same direction. Since F and delta P are vector quantity, delta T is a scalar quantity, that this force is changing the object's motion in the same direction as the force itself. And if we do some algebra, we can see that P equals mv, so we can take the m out, and v times v plus m times delta v over delta t, which when the mass is constant, we can say that F equal to ma. However, if it's not, we can use this equation. This equation is actually derived from product rule in calculus. And let's talk about conservation momentum. Momentum in AP Physics 1 is usually conserved, and it's very useful when calculating objects' final velocity. And we can tell by the previous equation that when F equal to 0, the next external force equal to 0, then the momentum is conserved, right? Because when delta P equal to 0, then F is equal to 0. So let's talk about collisions. It's basically objects, they collide together, that they hit each other. And the other force on the object is much less than the force of interaction. So we can basically say that the next external force is 0. And which means that the momentum is conserved. And in isolated system, the momentum is always conserved. So there are two types of collisions: inelastic collision and elastic collision. Elastic collision, kinetic energy is conserved. No energy is transferred to other forms such as sound and heat. And conservation of momentum, since energy is conserved, conservation of energy. And if two objects have the same mass, they will actually switch the velocities. For example, if mass 1 and mass 2, it has initial velocity, let's say this 1 equal to 2. Let's say v1f, v2f. This v1f actually equal to 2 and v2f equal to 1, doing elastic collision. So inelastic collision, which means that kinetic energy is not conserved, so some energy is transferred to other types such as sound and heat. And we can only use the conservation of momentum equation to calculate the velocity. And thus, for inelastic collision, there's also perfect inelastic collision. Basically, two objects collide. They share the same common final velocity. And explosion is actually a type of collision, increased kinetic energy, because let's say you have an object that's not moving. It starts not moving, so V equal to 0, so the KE equal to 0. But it may blast into different parts. It might look like this. Momentum is still conserved. This go to left, this go to right, up, down. Momentum is conserved, but kinetic energy is actually increased because these pieces possess kinetic energy, so they're moving. So let's talk about 2D collision. So usually momentum is always conserved in both x and y direction. Since momentum is a vector, you can break it into x and y component. Final velocity, we can use the Pythagorean theorem to calculate. And let's talk about velocity center of mass. It's basically the total momentum of a system divided by the total mass. And this also shows that during a collision where there's no net external force, the velocity of center of mass will actually not change, no matter what the collision is. And now let's do some practice problems. So let's say you got a bullet has a mass of 0.03 kilogram, moving 3,000 kilometer per hour, and it hits a 5 kilogram block, and blah, 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 blah. Let's calculate how high the object will reach. Of course, no friction in physics. So first we want to convert to SI units. 3,000 kilogram per hour. We want to multiply, let's convert the time. 1/3600 and hour second. 1 hour has 3,600 seconds. And let's convert kilogram to meter. So we can put meter here, kilogram here, so it cancels out the units. 1 kilogram has 1,000 meter. And if we calculate that is 833.33 meter per second. Now we want to solve for the final velocity. And since it's a perfect inelastic collision, we can set up our conservation of momentum equation. Initial momentum equal to the final momentum. What does it mean? M1 V1 plus M2 V2 equal to M1 plus M2 times V3. Since it's a perfect inelastic collision, they stick together. Actually, let's call it VF. And there are vector quantities. Actually, let's leave them as scalar for right now. So we can solve for the velocity final equal to m1 v1 plus m2 v2 divided by m1 plus m2. So we can compute that 0.03. Actually, since the block is at rest, start at rest, then we can say that this part is 0. So that's 0.03 times 833.33 divided by 0.03 plus 10. So that's 2.49 meter per second. And now we calculate the initial velocity that the object about to go up this road. Now we can set up the conservation of mechanical energy equation since the friction is not present. So we can say total mechanical energy equal to the final kinetic energy. Initially, we only have kinetic energy. Since we're not going up anywhere, there's no spring present. And the final mechanical energy is at the highest point, which velocity is 0. So we only have mgh. Mass cancel out. So we get h equal to v squared over 2g. What's v? 2.49 squared over 2 times 9.8. Give us 0.317 meter. Okay, let's talk about the next one. Let's talk a little bit about application. How will an air mattress protect a stunned person landing on the ground? Well, air mattress, when the person hitting it, it will go down. This will deform. It will deform. It will ultimately looking like this, which means that there's continuously force acting on this person. However, it must have the same change in momentum, no matter if it's a hard road or it's an air mattress. So the impulse we can calculate is F delta T equal to M V final minus V initial. When this increase and this stays constant, momentum stays constant, then this must decrease. So since the amount of force acting on an object decrease, it will potentially save a person's life. So now let's talk about an exploding object. So a 2.0 kilogram object moving at 5 meters per second, exploding to 2 fragments, 1 fragment, that's called it M1, 1.2 kilogram, 4 meters per second in the same direction. And there's a second fragment, let's call it M2. We want to find the velocity. So let's don't care about part B right now, let's care about part A. So we want to solve for M2 first. That's 2.2 minus 1.2 gives us 0.8 kilogram. Now we want to settle the conservation of momentum here, since it didn't say the friction, there's friction there, so we can assume there's no friction. Momentum initial equal to momentum final. Initially, it's M total, V total, and now it breaks into 2 fragments, M1 times V1 plus M2 times V2. Now we want to solve for V2. That is M total V total minus M1 V1 divided by M2. Now we can solve for it. Total is 2 kilogram times initial velocity 5 minus the first component 1.2 kilogram times 4 meter per second by m2, which is 0.8. So we get 6.5 meter per second. That's the velocity of second block. We can see that kinetic energy increased even though it's exploding, and we gain extra energy in the system. Well, it transferred into kinetic energy. So, second question, if the explosion released 10 joules extra energy, let's see if this is possible. So, we want to calculate the initial kinetic energy. So that's 1/2 mv squared. So that's 1/2 times the initial mass, 2 kilogram, times 5 meter per second squared. No, 5 meter per second. So that's 25 joules. Let's calculate the final kinetic energy. So that's 1/2 times mass for the first segment, 1.2, times the velocity for the first segment, 4, then squared it, plus 1/2 times the mass, 0.8, times the velocity, 6.5, of course squared. That will give us 26.5 joules. And now we can calculate 26.5 minus 25. That's 1.5 joules. This interaction only costs 1.5 extra energy, 1.5 extra kinetic energy. So which means that there must be some sort of energy that's being transferred into heat or sound, because the explosion actually released 10 joules of energy from the system, and only 1.5 convert into kinetic. And now let's talk about recoil. And the question's gone, but basically, a 2.5 kilogram rifle that shoots a 50-gram bullet at 400 meter per second, no friction, of course, determine the recoil velocity. So there is conservation of momentum since no friction present. So that's the so initially they're not moving. They both are not moving before the shooting. So that's 0 actually. So 5, the mass of the rifle times the velocity of rifle, then plus, let's convert 50 gram into kilogram. So that is 0.05. Okay, that's 0.05. So now let's calculate it. Plus 0.05 times 400. VR equal to minus 0.05 times 400 divided by 5 equal to minus 4 meter per second. So we see that recoil, a bullet shoots this way. The rifle, let me just draw a quick rifle here. It's actually going this way. It actually makes sense because when you play a video game, you see that the gun actually going up. It is recoil that try to simulate it, but it's difficult for the game developer to actually move your whole body backward. So they choose to move the gun upward. And now last problem. So you got 2D collision. A 0.06 tennis ball traveling in 30 meters per second stroke X ball at angle 45 degree and rebounds elastically at the same speed and angle. The collision lasts 0.01 second. Determine the impulse imparted to the ball by the wall. Well, let's see. So there's a wall, an object shoots it 45 degrees. Well, let's draw a better 45. That's a 45 degree here. And it bounces elastically with the same speed and angle. Well, when the ball hits the wall, it only provides force to the left. Why? Because the normal force is the force that changes the motion by the wall, of course. What does normal mean? It's perpendicular. This force acting by the wall must be perpendicular to the direction of the wall, which means that it doesn't cause the vertical change in motion. So which means that all the force that it changed the momentum is all horizontally. So let's calculate it. So we know that J equal to F delta T equal to delta P, which equal to mass times velocity naught. Okay, since it rebounds at the same speed, so this all x direction, assumes all x direction, let's use this formula. Jx equal to mass, which is 0.06 times the final velocity, which is negative 30, since that's the same speed and it's opposite direction. So 30 becomes negative 30, minus the initial velocity, 30. 0.06 times minus 60 give us negative 3.6 Newton second. Well, we got that, then we can calculate the average force. This F average delta T equal to minus 3.6. So F average, see that time is 0.01 seconds. So that's minus 360 Newton to the right, or 360 Newton to the right. Or to the left, I mean. 360 Newton to the left. And that concludes my video for this chapter. And please like and subscribe, and see you next time.